songs written in Python. Okay. Let's see. I still got a couple of minutes before I should get started because I don't think they activate the let you get your CPEs till the end of the time. But while I got a couple minutes, let me show you this vulnerability. Yep. Oh, hey, how have you been? No, good to see you, by the way. So let me show you just a vulnerability, a way you can bypass some antivirus software and some application whitelisting systems that still exist in the Windows operating system, even though it's been forever since this was reported to Microsoft. So let's just start in the Windows directory, and then we'll start with this. All right, so in this folder, you'll see 2 copies of Explorer.exe. That should be a sign that something is bad, right? Because, well, first of all, can you have 2 files with the exact same file name in a directory? No, right? As soon as you put a second file in the directory, it puts open parentheses 1 after it, so something odd is going on here. So that's command prompt. Right? One of the things that SANS will teach you in 504 is never trust anything that your computer tells you. Right? Always ask it the same question multiple ways. Ask it from the command line. Ask it from the graphical user interface. Ask it the same question multiple ways. And how do I make this bigger? All right. Well, all right. That's big enough, I guess. So let's ask the same question here in PowerShell. CD into our Windows directory. And then I'm going to ls expl. Typing is so hard. All right, so here I do the same thing in PowerShell. And you can see that explorer.exe, according to PowerShell, these 2 files are the same the same size on Windows, or excuse me, in PowerShell, but they're different sizes in the command prompt. That's a little odd, right? So let's just say this is an incident response, and I want to figure out what's going on with this thing. I want to dig into this and find out what's happening. What are some things you might try here to figure out which one of these is the legit Explorer.exe? What you got? Looking for alternate data streams. I could check the processes and see what's going on. If I check the processes, well, what am I going to see there? It's going to be 2 things running in /Windows, right? It's going to be 2 Explorer.exe. It's going to be the same there. How could I tell how could I go to a good operating system, find Explorer.exe, and then compare it to that one? What could I use to compare them? What's that? A hash? I heard somebody say hash. Let's try some file hashes, right? So in PowerShell, there's a commandlet that comes with it, get file hash dash algorithm MD5. Can you see that? Okay. I don't know why my control shift, because I'm not in terminal is why. Here, let's do terminal. Do I have terminal on here? Terminal app is so much better than the PowerShell app because control shift plus, right? Look at that. There we go. All right, CD to Windows. And then I can get file hash algorithm MD5. All right, so same MD5 hashes, same SHA-1, SHA-256. All right, so all the hashes are the same, okay? But all the hashes are the same, but one of them is 5 megabytes and one of them is 700 kilobytes. Does that sit well with you? Anybody have a problem with that? All right. What are some other things I could do? Well, I could check the digital signatures using SigCheck. Tool that comes from Microsoft, so let's do that. I actually conveniently have a copy of that on my hard drive, /SigCheck. And let's just look for the digital signatures on these things, because Microsoft digitally signs everything that comes with the operating system. They're both digitally signed by Microsoft. All right. So let's just get to the punchline, because now I'm late for my talk. One of these is a copy of PuTTY, the SSH client. My copy of PuTTY, the SSH client, is digitally signed by Microsoft, and it contains all of the same hashes as Explorer.exe. So what does your antivirus software do when it sees that something is digitally signed by Microsoft? Not going to waste any of my time scanning that one, right? And, well, I just digitally signed PuTTY. How in the world did you work this magic, Mark? Did you steal an SSL certificate from? No, I renamed it to Explorer.exe space. And by renaming PuTTY.exe to Explorer.exe space, it is now digitally signed by Microsoft, and it has all of the same hashes as Explorer.exe. Because there's a vulnerability in the operating system that when it goes to open a file, it trims trailing spaces. So when SIGCheck says, I need to open up Explorer.exe space, it calls the function trims the trailing space, actually opens up the legitimate Explorer.exe, scans that, right? When any type of file hashing, any antivirus software, anything that you want to, it actually scans Explorer and says, oh, there's nothing to see here. So this came in to me as an anonymous handler on SANS Internet Storm Center. I reported it to Microsoft, and they said, all right, well, we talked about it for a couple of months, and then they said, we're not going to fix it. And I said, all right, well, I'm going to start talking about this on Twitter. And they said, we've seen how many followers you have on Twitter, Mark. We're not that worried about that. Well, you just go right ahead and do that. So it hasn't been fixed. This is, and it's been Windows 8, right? I talked about this at B-Sides Augusta 2014, I think, is the first time I started talking about this, and so that's not out there. All right, so that's the issue. The exploitation of this, you do not have to put this inside of C:\Windows, right? The way that I use this in my penetration tests is I will stand up a share on my computer. I will put a copy of Explorer.exe on my share. I'll put a copy of Meterpreter, whatever it is that I would like to bypass antivirus software, also in the same share. And when it opens it up across the file share, it again trims that trailing space and ignores it and sees it as digitally signed by Microsoft. So there's that. And so with that, welcome to my talk. My name is Mark Baggett, and I'm here to talk to you about the Hacker's Guide to Environmental Catastrophe. Despite the hook that I had in the description, this is not about the environment outside. Even though in submitting the CPEs to the 3 different organizations to get it approved so you could get your CPEs at the end, it's one of the 3 organizations that we submitted it to. It wasn't GIAC, I'll say that. Did deny the talk, said it wasn't a technical talk. They never made it past the tagline of, even though Fox News knows it, and CNN and Greta Thunberg, this is not about the environment. This is actually a technical talk. So what am I going to talk about here? Well, first let me tell you who I am. My name is Mark Baggett. I do penetration testing and incident response. I'm a senior instructor for the SANS Institute. I'm the author of their course 573, which is Automating Information Security with Python, and the author of the new course that's coming out actually October 1st is going to be our first beta run of 673. I'm really excited about that one. And I'm the co-author of 406, which is going to be an introduction to Linux security, which we're going to talk about. I'll show you a little bit of the lab environment that we've been building for that one. I'm excited about those 2 new classes. A little bit. I am here in Augusta. I live in Augusta. One of the founders of B-Sides Augusta, which is happening in October 1st. So any locals or any vendors who would also like to sponsor another amazing conference here in Augusta, Georgia, you still have a chance to sign up for or sponsor B-Sides Augusta. I'm the author of several tools that are used. One of them, SrumDump, is actually pretty, I've got a pretty good user base of tools that are out there. But there's also Freak.py, Domain Stats, and a couple of other tools that several people in the information security community support. I did not write anything for the Metasploit framework, but if you grep for my name in the Metasploit framework, I do appear in the Metasploit framework 7 times based upon other TTPs and things like that I've developed that other people have been kind enough to give me credit for in the Metasploit framework. This tweet is the catalyst for this talk, right? So I signed on to Twitter, which is always a bad idea if you're in a good mood. But I signed into Twitter, and I went out, and somebody had tweeted this. They said, I'd like to thank whoever decided it was cool to shove secrets and passwords and tokens and stuff into environment variables. It makes attacking stuff so much easier. And I was like, yeah. And actually, I had just been working on a test where I was trying to get some information out of environment variables and was struggling with it a bit. And I saw this tweet, and so I responded back to the tweet. I'm like, yeah, how did you get the environment variables out of this? And like the internet trolls just came out and had me for breakfast, right? It's like, I used the env command, Mark. It's like, oh, well, okay. Yes, I get it. But his point is actually really valid. There is a lot of information that's being put into environment variables that's sensitive, that we should care about, right? All these new cloud services, right? Have you looked at the extensive amount of variables that you set or can set when you're using like the Amazon command line interface? Right? You can set your own keys, the names of your domains, all kinds of sensitive stuff. What you see down here, this is the Django Web Framework. I just pulled out some of the source code here. And every place you see os.getEnvironment, this is Python, where they are pulling an environment variable that has some configuration data for the application. You can see they've got app secrets, debugs, they've got database names, database usernames, database passwords, database hosts, database passwords. All kinds of information is being stored in environment variables. So after embarrassing myself on Twitter with the question of how do you get these things, and then wanting to redeem myself by saying, there's a bit more to it than just typing the env command, I wanted to just talk for a little bit about environment variables, how they work in Linux, and the different levels of security that you actually have around them. So let's start out. I'm not a fan of, even though I took the time to colorize my slides with input in green and output in red, let's look at some of this stuff in demo mode, because I think that's more interesting when I demo it. So if I wanted to create, Control L, if I wanted to create an environment variable here, I could say API secrets equals, right, and then some value, top secret. Now, it is important that when you put the equal sign there, that you don't put spaces around there, right? And this created an environment variable in Linux. If I want to see what environment variable or the value of that, I can echo it. When you echo it, you put a $ in front of the environment variable, and that'll show me that value. What did I do wrong? Oh, secrets. There is no API. Thank you. So glad you're here. I displayed the environment variable. Okay. Now, this environment variable, sometimes these are actually referred to as shell variables or local variables, because that environment variable can't actually be used to configure an environment, right? No other application can see this. If I was to write another process, if I was to run a Python program or a web framework or something in here, it actually could not get that value. As a matter of fact, what I'll do is I'll do this. I'll do bash -c. So what this is going to do is launch a new bash prompt. And inside that bash prompt, what I want to do is echo $API secrets. Okay, oops, and I want this to be in single quotes, not in backticks. All right, so when it runs that command inside of that bash prompt, it didn't see it, right? It came back with nothing, and I spelled secrets right. So it's not there. It's only available inside of this exact shell, inside of this process that I'm running, inside of process, echo $, tell me what my process ID number is. It is only available inside of process 92493. That's it. None of its subprocesses. Another way you can see this is if you type set and then you grep for it, it does show up in set, but it doesn't show up when you run the env command. The env command shows you those environment variables that have been exported, that are available to other subprocesses. So if I want to make that environment available to things like web frameworks and other things that I run from within this shell, I've got to export it. So I do an export API secrets. Okay, and then shows up in set, and it shows up in env. And then if I do my bash process, which didn't work before, now that bash process can see it. Okay. So there's already two different kind of levels of API environment variables. Now, one easy way to steal environment variables, if you break into something, and let's say that there's a web framework running, and the situation that I had was I was on a host where there was a web framework running, and I wanted to get the environment variables that were set inside of that environment, web framework. So how could I do that? Well, one easy way I could do that is you can type the word history, right? So anytime you run a command like setting an environment variable, something like that, it shows up in the history. But there's a very easy way to prevent your environment variables from showing up in your history, and that is just put a space in front of things. So if I type space and then create a new environment variable, new env equals hidden from history. Just the mere fact that that I put a space here in front of this means that it will not be recorded in the history. Okay, so now if I type history, it's not there, but if I echo $new env, right, it is there. So just merely putting a space in front of things and that goes for any command line. Think about, you run SSH commands, you pass a password on the command line. Anytime you're doing things in a Linux prompts and you don't want it recorded in your history, just put a space there, and that'll prevent it from being recorded in your history. So that's one thing we can do to prevent those. Let me look at my slides and see where I am in my slides, because I've shown you this. All right, we can create environment variables. If you don't export it, it shows up in set, does not show up in env. Let's see. Sub-processes like bash don't see it, but then when you export it, they do see them. And so who can see an environment variable? If you do not export it, the only process that can see it is the process where you ran the set command. We'll call that one the parent process. If you do export it, then the process where you created the environment variable can see it. Any commands you launch in that, we'll call those child processes, or we'll call that the process, like the web framework that you run there could see it, and then any child processes of that framework could see it. So all of these things will show up in your history. So if you, this is something different. What if I wanted to hide things from sibling processes, right? So the parent process can see something. The thing where you do the set can see it. Then the web framework can see it. And then any of its child processes can see it. I can set it so that the web framework will see it and its child processes, but not the process that actually sets the environment variable by setting it on the command line. So I can here, let's say new env2 equals blah, okay? And then on this same line, I'm going to run bash -c echo new env2. Right? So what this is going to do is from this one time, it's going to create this environment variable called new env2, make it available to the sub-process here, which was going to be this bash process, but actually in this parent process, the one that actually where I ran that command, new env2, it's not there. Right? So that is some level of protection that we could offer to these environment variables, is make it so it's only available in the child process and not actually in the process where we're creating it, and then combine that with spaces, and all right, well, now it's just available in the child process. And now we're down to the situation where I was belittled by the people. Okay, this is it doesn't show up in your history if you add a space. And whether or not it ignores those commands that have a space in front of it is controlled by an environment variable, right? So you have the environment variable called histcontrol. Histcontrol can be set to both. It can be set to ignore space, or it can be set to ignore dupes. Ignore dupes says if you have duplicate entries, don't record it in history. Ignore space says if you have spaces, don't record it in history. And ignore both says ignore both of them. All right. So let's look at the two different scenarios where I might be breaking into a system and trying to steal API keys or other sensitive information that's kept in environment variables. Let's say I have a web server, and it has some API keys stored in it, which is the scenario that originated this tweet. Over here, I've got a little web server called APIify. And what APIify does is it's actually something you can get off of my GitHub page. It's a tool that you can use to take any Linux command and run that command, turn it into a JSON response that you can collect up into some type of a security event management platform. And it'll also cache the entries and give you back that same response again. So the way that it works here is it comes with this little, code APIify.yaml. And what you do in this YAML file is you configure the command that you want it to run and some options. In this case, I've just got it running the command ping-c1 and then whatever I put on the URL that I pass this command. It does have the ability to block command line injections. Well, I've changed it from its default value of blocking command injection attacks. I've set it to false. So this is vulnerable to a command injection attack, but it's only because I've done this. Okay, so I don't want you to think that I've released a tool that is vulnerable to this attack. It is when you set it to false, but by default, it's perfectly fine to run APIify. All right, so over here, I'm going to run APIify. So let's just run it. Python APIify. It starts up a little web server. And then I could open up a browser here, but if I do a browser, it's going to be really small and hard to see in the back. So what I'm going to do is I'm going to use wget to interact with this. So I'm going to send a request off to my APIify, and I'm going to pass it the IP address 8.8.8.8. Oh, I don't have internet, do I? All right. And it's going to come back with network unreachable. All right. I should have gotten this thing on the internet before I could. Oh, that is. It says I do have internet access here. Well, I don't need it to have internet access for what I'm doing. Let's see here. What if I change this command here, and I put a semicolon, and I do an ID? All right, so now, in addition to the network unreachable, you can see that it also ran the ID command. Okay, so it's got a command injection of vulnerability. So I can put multiple things on this system. So let's do this. Instead of typing ID here, let me make it a little smaller. So let's type set pipe grep, API. And let's look for the API environment variable. All right. So this, because I set that API secrets in this shell, right, it sees that environment variable. If I do the same thing that I did earlier where over here in API, if I create some environment variable that's only accessible to APIify, let's say new env3 equals Mark was here, and then I'm going to do a sudo APIify. All right, so no. All right, so now it's running, and if I live demos, I just can't type. All right, so there's all my environment variables, and in here, if I look, let's see here. What was the environment variable that I just created? I created one called new env3. Okay, so I should be able to see that inside of this APIify. Set pipe grep for new env. Doesn't like my grep. Let's see. Not sure what I did there. Let's see. If I just see set, do I see it there? Well, what I want you to see is that we can gain access to the environment variables. I was going to try and find that specific environment variable, but here I can gain access to the environment variables through command injections. And that's actually the scenario that they were talking about on the web. But my question is, if in the scenario I was in specifically, I was able to, they had an FTP server on the same thing as they had the web server, and I was able to guess a password to the FTP user, browse around, and then able to find a password for the service that was running the web account. And then I was on the process, I was on that server as the web account, but a sibling process, right? I wasn't in the web service process itself, I was just on the server as that user. Now, can I gain access to those processes? Well, there's a couple of ways that you can gain access to environment variables on the system itself. So in the scenario where I gain access to the web server through a vulnerability, I've SSH'd in, can I gain access to those environment variables? One way that you could potentially do that is through the Proc Directory, right? And this is the first place I went to go and try and find it, right? Every time Linux starts a new process, it creates this, in the proc folder, it creates a directory that matches that process ID number. And inside of that directory, it keeps all kinds of information about that process. So over here in APIify, let's see, let's find out what my process number is for APIify. Let's do a PSAU. And here's where I'm running. Oh, I'm running two APIifys. That's probably why why I'm running into problems. Let's look inside of this process ID number 49641. Okay, so I'm going to CD into that 94641. If I change into that directory, and I do an ls, I can see all kinds of information about that process, including this one called environs. Right? So if I cat environs, I can see the environment variables that were created when this thing launched, including, let's see here, I'm looking for one of those interesting ones that I created. Let's see. Does anybody see it? See the API secrets or anything amongst that mix? All right, let's try the other process. What was the other process that I looked at? PSAU. Let's try this one. Process 94638. CD ... CD 94638. And then cat environs. All right, if we look down here, oh, there's my API secret right there. Okay, so grabbing them out of the proc directory would be something I could try, and that's the first thing I actually tried when I got on the system. But when I looked, the things that I wanted weren't there. They were not set on this particular process during my pen test. And I was like, why would those things not be there? So I did some investigation and looked into this, and as it turns out, proc only records environment variables when the process is initially launched. So if a web server process was to start and then create environment variables after it started, maybe by reading things out of a configuration file and then loading those up, those are actually not available inside of proc. Right, so here in this other system, I create this API key called top secret. I look at my process ID number, and it's called my process ID number is 60560. And then that's the process ID number of this bash prompt. And so then I say, show me this key inside of that bash prompt, and it's not there. The reason it's not there is because, well, this environment variable was set in the process, or in that bash process while it was running, not at the start of the bash process. So this is another way that we can protect our environment variables is to not have them set when the process first launches. And I thought, wait a minute. If I'm on this system, I can get these process environment variables. I can grab them out of memory, right? If I'm on the same system, I can grab them out of memory. So I wrote a little tool to steal these things from memory. And this tool is available. It's on my. It's not on my GitHub page. If you go out to GitHub, it's there. It's on Github Gists. You guys know what the Github Gists are? So you got GitHub where you can publish entire packages and things like that. But you can also publish just gists. Gists are just like one-line files or even notes for yourselves or something like that. So if you go to gist.github.com, Mark Baggett, you'll find this Python program I wrote called dump process variables. And what it does is it can dump process variables even after they have been launched. So, because what it's going to do is it's going to attach the debugger to the process, and it's going to step through it using GEB. It's going to step through memory, find those environment variables, and extract them. Okay, and well, it works pretty well. I can show you. I got a this was process 94638. If I type Python home /home student, I think I put it on my desktop, dump envs 9. What was my process number? 94638. 94638. Right, goes through and it finds the environment variables from memory and it extracts them directly from memory. So even if it's been set after the process has been initially launched, this can grab those processes. But there's some limitations to this, is what I found out during the test. And that was even with this, I could dump them on my own process, on my own system, but I couldn't dump them on the web server where I was trying to use this process. And I was like, why isn't this working? And as it turns out, Linux actually has a bit more security than I anticipated that it did. You cannot steal anything from memory from a sibling process if you are the same. So if you're the same user that launched it. So I've got a web service running, and it's running under the web service account. I hack in, and then I'm also on the same server as the web server service account. This sibling process cannot dump the memory of another sibling process. You can only dump the memory of child processes that have the same name. Root, of course, can dump anyone's memory processes, but a sibling, you cannot dump the process of a sibling process. And this is actually controllable by a configuration file that you have on your system. Under AFCEA system control 10, the ptrace configuration file controls whether or not you can dump, whether or not like the web service account could dump any web service account or just its sibling processes. And by default, it's set so that you can only dump your own child processes. You cannot dump sibling processes. To change this file, you have to be root, and it does require a reboot. So once again, I was kind of stuck, right? I couldn't get there from where I was going. So this is actually a really good thing. From a configuration standpoint, I think one of the best things we can do is, one, don't put our environment variables in history files. That would be a good start. Two, don't set those environment variables before the process starts so that it's not recorded in /proc. So what we want to have happen is have the processes run under, make sure nobody can get to root where they can dump any thing from any place. Don't have them in history. Don't set them before the process. And then just have the web server process set environment variables after they load. Maybe keep those in a secure configuration on the machine. Yeah. You can't keep it in a clear text configuration or anything on your machine because then the attacker can just grab those files off of your scene. But if I could have some type of a configuration that was encrypted and then loaded up, then that would solve this problem for me. Well, the encryption isn't there, but why use environment variables at that point? Why not just have my web service just load configuration files off of the system, at which point they're not stored as environment variables and they can't just be stolen through web injection attacks? Now, if it's still sitting on the file, they can still go and grab those files. That's why we want to use encryption on those files. But that's better than environment variables, in my opinion. But using configuration files on our web servers is not without problems either, right? A common use for this, particularly with the Python-based web frameworks, is to use a .env file. As a matter of fact, lots of people say, hey, use these .env files. They're very popular for web frameworks like Laravel, CI, and others. This is what Stack Overflow says about them. They say, yeah, use env files. They're great. Everybody should do this. This is what Google says about them, right? So if you go to Google and you just look for file type env, and then you search for, I don't know, things that might be inside of env files, like db username, comes back with, well, different people's env files. So this is, I'm looking at this and I'm thinking that this database name here, this is not an example configuration that somebody has out here. This is finding legitimate, this Google search is just finding where people have put env files in their system, right? So that's the downside of your alternatives to environment variables is, well, if it's a configuration file and it's just sitting in the file system with those web servers, then, well, Google can index it and people can just search for and get access to your passwords. So, yeah, don't keep those environment variables in a directory that is searchable, that Google can find these things. The other thing that happens with that developers do with these env files, they put them in there and then they commit them to their GitHub pages, right, or their GitHub repositories. And once you put that stuff into GitHub, getting it out of GitHub, right, is not trivial, right? There's tools out there that will search through GitHub revision history to find where people have accidentally committed these passwords and things like that. Trufflehog is one of those tools that will find these things. Configuration files are not without their own problems as well. So neither of those are great alternatives, but at least now you know the different options you've got available for them. There's another side to environment variables that I wanted to talk on, and that is hackers using environment variables in order to gain access to different systems. I just want to show you these 3 web pages, which I've already pulled up for you here. This first one is on using environment variables in order to exploit systems. Right? There's lots of different programs out there that have environment variables that it checks for like scripts that it'll automatically launch. For example, Perl. Perl will look through this Perl 5 opt environment variable and others, and if it contains Perl scripts, then it'll automatically run those Perl scripts whenever you run any other Perl scripts. Right? So you can use these as ways of backdooring these interpreters. I wish I could tell you that Python does not do the same thing, but it does, right? The Python startup environment variable. Right? If I can get on a system and set this environment variable to point Python startup at any Python script I want, then anytime anybody uses any Python scripts on that system, in addition to running the Python scripts that they want, they're going to also run whatever Python scripts I've pointed this environment variable to. And it's not just Perl and Python; it's lots of different systems out there. So if you're interested in that, you can just search for hacking with environment variables, and that will give it out there. That'll give it to you. But one of the things that we've seen a couple of different reports on recently that I think is really interesting is the use of the environment variable LD preload. Okay. LD preload on a Linux system is a very important environment variable. It controls whether or not a process uses Linux shared object libraries, right? The .so files you've got on your Linux systems. The way that those work by default is when you launch a process, if your parent process has already loaded up one of these libraries into memory, and you want to use that same library, then you just don't, right? You just use the one that your parent process has already loaded for you. Those are shared object libraries. But it's hierarchical, and it's based upon which ones are in your parent process. When a child process is launched, it'll check this environment variable for the names of any shared object libraries that it's not going to use, right? And then what it'll do is you can point this environment variable to a shared object library that you want it to load a unique version of. And this can lead to a couple of different types of interesting attacks. There are privilege escalation attacks that use this LD preload environment variable in order to, well, go from a low privileged account to a high privileged account. And very recently, Bruce Schneier posted a blog. What was the date on this one? June 22nd of 2022, talking about the Symbiote Linux malware. Symbiote Linux malware is an interesting piece of malware that actually uses this LD preload environment variable in order to, well, control Linux. It infects machines by creating a malicious shared object library and then telling all of the Linux processes not to use the one that comes with the parent process, but instead to use the one that's specified in the environment variable. So there's lots of cool things that we can do with hacking in environment variables, including one that this guy posted on Twitter. I love following this guy on Twitter. He posts all kinds of interesting things. So if I highly recommend, this is my Friday friend, what's today, Friday? No, this is my Monday friend follow. So if you're not following this guy on Twitter, I recommend. He posted this thing about this cool little keylogger, right? If you want to implement a keylogger, you can implement a keylogger with just an environment variable. And let me show you how this one works. I'm going to demo it over here. So let's see. I think I've got it in my history that I can recall it here. Control R, while. Nope, it's not in that one. Maybe it's in this one. Control R, while. All right. No. All right. It's not in any of these. What I'm going to do is I'm just going to type out the commands. So what I'm going to say is while. Make it a little bigger for you. While one. Do. What I want to do is I'm going to say netcat listen on port 9000. Done. I forgot my semicolon here. While true. While one. I can never remember where to put the semicolons when I do the while loop, so I always type them out. Do netcat listen on port 9000. Done. All right, so I've got a little while loop that's listening on port 9000 here. All right, so this is just my netcat listener. This is the attacker's netcat listener. And then in some victim, right, well, in the system where I want to launch my keylogger, I'm going to set one environment variable. Okay, this is my victim. And what's the environment variable? I'm just going to steal it from over here. All right, I'm going to set the command prompt. Command prompt is an interesting environment variable. What the command prompt environment variable does is it says, hey, every time you run a command, or every time the prompt is generated in bash, I want you to then run this command. So my prompt command says, every time you generate a prompt, run the command history-a. History-a says take whatever, commit the things that are currently in memory for the history and commit them to a file, to the bash history file. And then I'm going to use the tail command to grab the last entry from the history, which basically that says take the command I just recorded, or I just typed, record it in history, then grab it from the history file, and then send it across dev TCP attacker's IP address, port that netcat is listening on. Okay? So this is my while loop that this is pointing to. And so now every time in this bash prompt, right, I type a new command, right, it appears in the netcat window that's running behind it. Right? So this is just an environment variable. But by setting this environment variable, I've now implemented a keylogger. You'll notice I'm not getting any output, right? Because it's not an output logger. It's a keylogger, right? So I'm only getting the things that I've recorded, or I'm typing at this, but still, it's a keylogger that we get to set through an environment variable, okay? So environment variables can be pretty useful in launching attacks as well, okay? This slide's regarding dumping memory, right? So when it comes to dumping memory, this is something else that I've found to be useful, and that is just stealing GitHub credentials, right? As a developer, right, you get tired of getting git pulls and git push over and over and over again. So what you can do is you can run this little tool called the Get Credential Assistant, which will remember your credentials for a period of time and then automatically log you back into systems, right? But of course, that's just stored in memory. So here I just did a process list, and I got the process ID number for this Get credential. And then anytime you want to dump memory from any process, you can use the gcore process. So use sudo gcore to run and create this file called temp process memory from this process ID number. And that dumps all of the memory from the process for this Get credential, and then I'm just using strings to go through it. Okay? I throw this out there as just another attempt to get you to follow me on my Twitter account there where I post stuff like this. And also to say that this is also something that is protected by that ptrace configuration file that is we set in the Linux security. So again, you can't get to this stuff if you are in a sibling process. You can only get to this stuff if you are in a child process that is running as there, or of course as root. You can't get to it. You can always get to it if you're root. All right. So with that, what is my summary of this talk? My summary is there's lots and lots of stuff that's being kept in environment variables. More and more stuff as we move to the cloud and we start configuring all of our API keys and things like that being stored in the cloud. You can reduce the risk of people gaining access to these keys and stealing them by, one, not storing it in your history. And of course, you can do that. It's usually as simple as putting a space before that command. Next, not having those things set before the process is launched. That'll keep them out of the /proc directory where they are easily read. By the way, who can read your proc folder? Root and, well, the person who launched it, regardless of subprocess. So web server can always read web server's process, even if it's a sibling process. You can always get to that. So it's not quite as secure as dumping memory. Proc is easily accessible. So ideally, you could store them inside of some type of an encrypted file and then have that thing loaded after the process has been launched instead of before the process has been launched. But in order to do that, it really means that you're going to be writing custom code in order to do that. If you don't know how to write that custom code, I might point you at my class, SEC 573, Automating Information Security with Python. What I wanted to show you is this last lab that one of the labs that we have in SEC 406, which is the new Introduction to Linux Security class that should be coming out sometime in 2023. The vision of this course was to have it be highly hands-on and have it be things that you could even just sit down and teach yourself Linux security by just going through and doing the labs. So this is the environment variables lab from 406, still in development, but it'll give you an idea of this. Now, the color scheme that I chose for my screen here perhaps is not the best for this one. I'm sure that when we release this thing, we'll have a better color scheme where this green will not be as faded out as you can see it. But you can see here, what happens is you drop into this environment. First, I got to log in as my student password. All right, I'm dropped into a Linux environment. This is a full Linux shell. I can do whatever I want to in here. I can run lsid. Right? I can do whatever I want to in this Linux environment. But the only way that I'm going to advance through the labs is by answering the questions that you have here in the bottom status window. So down here at the bottom, we got a window that's telling us what it is that we need to do to move through the lab. We got a set of boxes over here that's tracking our progress, telling what we have to do. It says first we need to run the env command to see all of the global environment variables. So over here, I'll type env, and it will come back and it'll show me the environment variable. The process then recognizes that, hey, you've done what you were supposed to do, and it'll do some things like tell you, all right, now we're going to play a game. It's going to give us a description of some important environment variables, and then we have to echo the contents of these. So it says to use echo to display the contents of the environment variable that contains the printed working directory. And if I'm not sure how to do that, this thing does have #hint. I can type #hint, and it'll give me some hints. It says the name of the environment variable is pwd. I can ask for another hint, and it'll tell me, okay, try this. Enter echo $pwd. So it's got the hand holding there to walk me through this process. If I forget what question I'm working on, I can #, go back to my question, right? But I know what I got to do here. I got to echo $pwd. And you can see that every time I complete a lab, I get another checkbox that comes up over here letting me know that I'm progressing through the lab, and it's going to walk me through these steps. Okay? So this is intended to be, if you're a Windows administrator. Right? I found that even in my own career, I learned security on Windows first. Right? I learned how to do those things. But when I got into information security, you know what? Everything is running on Linux. If I wanted to run Security Onion, if I want to run Snort, if I want to run TCP dump, I got to kind of know some Linux to really become efficient as an information security professional. And so this is really targeted as an introduction into information security with Linux. So it's going to teach you about environment variables, how to create folders, permissions, all of these kind of things, create service accounts, cron jobs, logging, and things like that. And that's just a little bit of preview into the lab environment that we're creating for theirs and how to work through environment variables. Okay, that's what I have for you. Are there questions about environment variables, about the vulnerability that I showed you in Windows, about songs written in Python? Because I don't think that you can scan your badges for another 5 minutes. I have to entertain you for another 5 minutes before you can scan your badges. Questions? No questions? Okay.
The grading on that, is that a specific, or are you looking for results?
How am I looking for this?
Yeah.
I have a combination. Without getting into too much technical detail, I have hooked standard input. I have hooked standard output. I've got those running through engines that are looking for both input and output. It's not just based upon what you type. If you can get to, all right, this next one says, get your home directory, right? Is there some other way to echo what your home directory is other than typing echo $home? I might be able to say echo /home/student and see if that works. If it does work, then I will add something so that it actually forces you to environment, right? Yep. See? So in many cases, I don't necessarily care about how you get to the answer, as long as you get to the answer. So this solves problems like if you want to echo your current working directory, you can just echo period, right? And that would work on Windows. It doesn't work on or echo enter would work on Windows. Let's see. How can I echo my current directory in more than one way? Well, what's this next one? Get a list. Echo your path. So how could I echo my path without echoing my path? I only know how to echo my path. If you do it in some other unique way, like if I use backticks to do it instead of just the regular thing. If I do something like that, right? I've tried to write it so you can just come to the correct answer any way that you want to, and not just have to type one specific type of input in order to do it. So, unless the question tells you to type some specific input, in which point it does it. Yeah. Thanks for that question. Other questions? Okay. Let's go back to, since we got a couple more minutes for you to badge. If I'm done. If you don't need to scan your badge, and you're not going to hurt my feelings if you walk out. But how would I create this malicious file on my hard drive? I'll tell you what you don't want to do. Since I've already shown you this, some of you might go try this. What you don't want to do is this: copy putty.exe to explorer.exe space. Anybody know why you don't want to do that? It's going to trim the trailing space. And what is it going to overwrite? Explorer.exe. Okay, so that is not how to create a digitally signed copy of putty. Okay, what you've got to do in order to make this file that contains the space at the trailing end, we're going to have to use what they refer to as device objects. So what I'll do is I'll refer to this as whack whack, and then C:\Windows/Explorer.exe. So if I give it that whack whack, and then the full path to the file, then that goes through an API that does not trim trailing spaces, and that will actually create that Explorer.exe with that name. Okay. So there, I saved you from destroying your Windows system by erasing Explorer, putting a copy of putty.exe in there. Okay. All right. Still 2 minutes. And so, if you have any questions and you would like to reach out to me, my name is Mark Baggett. I'm building a new slide for just this 2 minutes. My Twitter handle is @MarkBaggett. I am email mbaggett@sans.org, and my phone number is 814-422-5632 should you ever need any of my services. Okay? All right. I think by the time you line up in front of that badge, they'll be ready to give you some CPs. I appreciate you hanging out until the end of the day and coming to see me in this talk. You guys have a great night and enjoy the rest of the conference. Thanks. It's going to be a great conference this year. I'm looking forward to it.